right, today's lesson, I cannot stress enough how important today's lesson is. Again, this is just a topic that I see consistently on AP over and over again. And yesterday we dealt with how do you use the first fundamental theorem of a sense. Is it okay to evaluate a definite integral? Yes, that is certainly a use for it. However, it's so much bigger than that. And that's where this lesson comes in. So remember what we talked about yesterday, and I'm writing it that second way we did, just so I don't have to write the big F and all that kind of stuff. If you have some function here, now it doesn't have to be labeled as the derivative, but saying that he is the derivative of somebody, you take the antiderivative and evaluate it, b, upper bound, minus the antiderivative and evaluate at the lower bound. So we talked about this yesterday. So, but what I want you to see is that what this is, I could honestly kind of write it this way. Ending amount of what you're talking about is the starting amount plus, and this part is the change. What I want you to understand is that when you take an integral, integration is the accumulation of change in a function f. So let's read this statement. If y of t, notice it doesn't have the derivative number on, mark, but it is the derivative of somebody. If y of t is the rate at which water flows into a reservoir at time t minutes, then what does the integral from 2 to 5 of y of t, what would that represent? And many times you have to write what that integral represents. Remember, there are three things. You explain it in words. It's the change in the amount of water in liters in the reservoir between 2 minutes and 5 minutes. Remember, your units can help you, because if you integrate liters per minute, because that was y of t, and then dt would be minutes. Remember, when you're integrating, you multiply the units together, so that integral is going to give you liters. The units can help you determine what you're talking about. So if you integrate a rate, because notice this is the rate at which water flows, what does the integral give you? It's the change in the amount of that thing. Okay, so let's look at this one. If W of t is the rate of growth of a child in pounds per year, what does the integral from 5 to 10 of WT dt represent? Now, again, write that like you're talking to a 12-year-old. Okay, don't talk area under the curve. Tell me, what does it mean? That integral would be, use units to help you. If it's pounds per year times year, that integral, when you get a number, it's going to be pounds. Well, think about what is measured in pounds. Okay, so this is going to be the change in a child's weight in pounds. So you tell what it is. What's the change in a child's weight? Units in pounds between, don't say in 5 years. You have to be specific with the time interval. Between his 5th and 10th year. Now, does it have to be exactly like that? No. If you said between the ages of 5 and 10, they'd give you credit. But again, you can see the three things: what it is, units, specific time interval. All three of those things have to be there. That's usually worth 1 point on the AP. And remember, they don't give partial points. So if you forget one little piece of that, you're not going to get that point. All right, number 2, a honeybee population starts with 100 bees and increases at a rate of nt bees per week. Write a formula that would represent the bee population at the end of the first K weeks. So here's what I want you to see. If I ask you the integral from 0 to k, the first k weeks, and I'm going to integrate this rate in bees per week, would that give me the number of bees? No, it doesn't give me the number. An integral is the accumulation of change. That integral gives me the change in the number of bees. So if let's say I got a number, and I'm just making this number up, if I got a number of 200 for that, that doesn't mean there's 200 bees after k weeks. What would I have to do? Well, I would have to take the starting amount and see what I have up here. See how I take the starting amount plus the change. So I would take the number of bees after k weeks would be 100 plus that integral. Now, I always like to put the 100 first because I just want to be very clear that that 100 is not in the integral, so I like to put it up there. If you put it at the end, that's fine, but boy, oh boy, friends, if you write this and you don't put the dt and you just put 100, you just lost it. You lost that point because they don't know if you're taking the integral of the nt, the plus 100, etc. So make sure, that's why I like to put it in the front. So it's very clear there that I've booked in the integral and then I add the 100. I really prefer this one. I get in the habit of doing it like that. So let's look at part B. Let's actually get a number. And it said, let n of t be equal to that equation. Find the population of bees after 14 weeks. Round to the nearest whole. So assuming this is on a calculator portion, because it will be, what would you have to write on your paper? Well, I would write, I always like to label number of bees after 14 weeks. Okay, don't put in a 14 because that's the rate at the 14th week. So make sure you're not labeling incorrectly. So if I have the number of bees, I would take the 100 that I started with. I'm going to take the integral from 0 to 14. Notice I just write the name. Like I talked about yesterday, friends, if you have the name of something, you do not want to write the whole equation. You just want to write the name. A lot less writing, save you time. So let me go to my calculator here. And I'm going to type in, again, normally I like to put it in Y1 since I know this is the only thing I'm doing with this problem. I can do it into Math 9. I can have my paper look exactly like, or my calculator look exactly like my paper. And my equation is 9 to the power of point, watch those decimals. It's real easy to mix, not have those. So there's my function, my integral. I hit enter, and then I read the question carefully. It said round to the nearest whole, and so I would get 403 bees. And what people do, here's what people mess up on. This is the answer that I get. They go, oh, cool. I'll just take the integral. I mean, I can tell you what this answer obviously is going to be without doing this. But if they type that in and they say, oh, there's 303 bees. Y'all, the integral gets the change. The integral is an accumulation of change. That's the change in the number of bees. It started with 100, so you have to add that in. So I want you to read number 3 and see if you can set it up and get my answer for there. So stop the video and try to do example 3. All right, what do we got? Pizza with a temperature of 95 degrees is put into 25 degrees Celsius room when t equals 0. The pizza's temperature is changing at a rate of, degrees Celsius per minute. Estimate the pizza's temperature when T equals 5. So I want you to think about what we're going to have. If I integrate, you pretty much guess that I'm going to integrate from 0 to 5 of R of T dt. But I want to be very clear. What is that going to give you? Is that going to give me the temperature? Well, if my units are degrees Celsius per minute, that's R of T, times minute, when those cancel, I get degrees. But it's the change in the degrees. Can I emphasize that enough? It's the change in the degrees. So it may, I can't just take that as my final answer. What was the degrees at time T equals 0? Well, it was 95. So I have to take the 95 plus the change. So this is my temperature, temp after 5 minutes is going to be equal to that right there. Again, do not put it's R of 5. It's not. That would be the rate that the pizza is changing at 5 minutes. That's not what it asks for. The temperature would be 95 plus that integral. So here we go, calculator. We love the calculator. Remember again, I could go to Math 8. If you like to put it in Y1, that's fine as well. I'll do that one this way since I did the other one the other way. You have options. So negative 6e to the negative 0.1 x. So there is my rate. That's R of T. So if I already have it in Y1, I can put 95 plus Math 9 from 0 to 5 of Y1. Get very quick at the calculator when you practice this. And then the calculator is going to give it to me. And I go to 3 decimal places. So I get 71.392. I've got a label. Make sure you don't just put degrees. You need to put either degrees Celsius or degrees Fahrenheit. So make sure you put that degrees Celsius there. And that's my answer. Now the back side, we'll use, actually the front side we used a calculator. The back side, we're not going to use a calculator at all because, again, this could be on the calculator or non-calculator parts. So your homework, I think it says, or you'll be kind of obvious of which one you should do. So let's look at this first one. It says the graph of f prime is shown. Given f of negative 2 is 7, find these things. Okay, interesting. Well, y'all, you're going to be using the first fundamental once again. So when you're doing that, so here's what I want you to see. Are you with me as we talked about before? If I integrate f prime dx, now I'm going to pick 0 and negative 2 because one of them is my given and one of them is my question. Which order I put them in, well, I like to go low to high. You can technically put them either way. I just always do it like that, no matter what I'm given and what the question is. Well, by the first fundamental theorem, that looks weird, that parentheses there. I don't know why I have those. That looks, I wrote that weird. Back there it is. That's better. Okay. If I integrate f prime, I would take the antiderivative, which is f. I would evaluate that at 0 minus, and I would evaluate top bound minus bottom bound. Do you see how where I get that? That's just an application of the first fundamental theorem. So if I'm looking for f of 0, are you in agreement that if I pop that guy over, that f of 0 would be equal to f of negative 2 plus the integral from negative 2 to 0 of f prime Well, what is f of negative 2? Well, f of negative 2 is 7. That was given. Now, how do I find this integral without a calculator? Well, miraculously, those are all geometrical shapes. So I can find the integral. So I know I'm going to have to find those areas. So let me go through and do that. Because I'm stopping at 0, I'm going to do each of these triangles separately. 1/2. Okay, I know you can do this in your head. The base is 2, the height is 4. So I get 4 here. That is the same. Now again, if you like to label them as negatives, if you're going low to high and you like to put negatives on those, that's fine if that helps you. With this triangle here, I could get that value, and I could do, sometimes, you know, depending on the problem, you have to break it up more, but that triangle would be 1/2. The base is 6. The height is 2. So I would get an area of 6 there. So the integral from negative 2 to 0, again, it's low bound to high bound. Negative 2 is less than. My f prime is below the x-axis, so I have to know that that integral is a negative, so I would get that f of 0 would be equal to 3. So this value, f of 0 is equal to, let's write it again, f of 0 is equal to 3. Okay? Now, with the other ones, I could actually do this, the rest of these, two different ways. Like some people would say, well, if I'm pretty confident that 0, f of 0 is 3, well, then I would be able to get and say, well, at 0, I'm 3. The change from 0 to 2 is negative 4. And they go, oh, 3 minus 4. And my answer would be negative 1. So they go off the previous one. Some people don't like to do that because they're like, well, gosh, if I messed up f of 0, then I'm messing up everything. So I could literally set up f of 2 and f of 8 the same way as I did up here. I would say f of 2. Again, how do I pick my bounds? Well, one is what's given, and one is what the question is. So I'm solving for f of 2. So f of 2 is going to be f of negative 2 plus the integral from negative 2 to 2 of f prime. So f of negative 2 was given as 7. From negative 2 to 2, again, below the x-axis, so minus 8. And notice I get negative 1. You do f of 8, whichever way you like better. I think by now you can be with me that f of 8 is going to be the start where I started at f of negative 2. I'll just go from the original plus the integral from negative 2 to 8, or the change. So I would have 7 plus the integral from negative 2 all the way to 8. I have 8 below, 6 above, so that would just be overall a minus 2. And I would get an answer of 5. Great, great questions here. Now number 5, let's kind of put it together. This one, very similar to what we did, they just kind of put it in word problem form. So let's see if we can kind of combine these things together. They love particles moving on the x-axis in such a way that the velocity from 0 to 9 is shown on the graph. The areas of section A, B, and C are 9, 8, and 2 respectively. So I'll put 9, 8, and 2. Kind of draw that on my picture. When is the particle moving to the right? And of course, it's going to say justify. So particles moving to the right. See if you can finish that. Particle moving right. When what? when velocity is positive or greater than or equal to 0. Greater than 0, not equal to. So when velocity is positive. So where, if this is velocity, I like to label my graph too so I know what I'm looking at every time I look at it. Where does that graph have positive y values? Well, this does say close 0 to 9. So from 0, notice that one's closed. Does the velocity have a positive value at 0? Yes. From 0 to 3, that one is open because remember when velocity is 0, it's standing still, so it can't be moving to the right. So 0 to 3. And in the same way, I'm going to have 7 to 9, but those are going to be open. Perfect. When is the particle at rest? Well, what's your justification? Particle at rest when velocity equals 0. So that's going to be at t equals 3, 7, and 9. And again, notice there aren't any, people always put units. Is there seconds or units weren't introduced, so we won't put units on our answer. Determine the, well, I guess it says it down here, seconds. I guess it probably should say it up there too. I'll add that in, so your notes will probably have it. All right, determine the displacement of the particle over 0 to 9, and likely, and letter D says the total distance traveled. Friends, it's those formulas that you have to memorize. Displacement is the integral from 0. What is displacement? It's the change in position, right? So displacement is just going to be, and you would have to write this on your paper, even though you're going to figure it out in your head, you would have to find that integral. And then the total distance traveled, remember, is when you have the absolute value of velocity. So with this guy here, with letter C, again, those negatives are a really big deal. The 9 is above, the 8 is below, and the 2 is above. So the displacement is going to be 3, meaning he's moved 3 units to the right. Okay? Whereas the total distance traveled, you're just going to add up all those areas. He traveled a total of 19 units. Okay? Now let's look at E. E says, given the particle's position at t equals 0 is -1, find its position at those times. Well, I hope that you see this question here as the exact same as example 4. Okay? And what that is that, okay, if they want the position x of, and they used x for position, what are my x values? I have 0 and 3. So if I took the integral from 0 to 3 of velocity, what would that be equal to? Well, the antiderivative of velocity is position. I'm going to use x because that's what they did. I would take x of 3 minus x of 0. Well, if I do that, then if I'm looking for this, I think you're with me that the position at 3 would be equal to, pop this guy over to the other side. So x of 0, I started plus the change. What was the change? From 0 to 3, right here, the change was 9, and I'd get the position at 3 would be 8. Now remember, I'm going to do these the fast way. I'm pretty confident that I got that one right. So y'all, think about 7. If it right here, at this time, my position is 8, I'm on a number line. I'm at 8. Because right here at 3 seconds. At 7 seconds, what was my displacement? Do you see that I went 8 units to the left? I would be moving to the left because velocity is negative. So if I moved 8 to the left, the starting position was 8. What was the change? I went 8 to the left, so my position would be 0. And then finally at 9, once again, at 7 seconds, I would be at a position of 0. My displacement would be 9, so my position at 9 would be equal to 2. Now this is a bonus question. I think it's a good one. Again, you'll see on the AP test how they kind of combine things. What if I ask you, and I might add this in, so it may be already printed on yours, when is acceleration negative? When would the acceleration of that particle from 0 to 9 be negative? Well, if this is velocity, what am I asking? I'm asking, you know that the derivative of velocity is acceleration. So in a sense, I'm asking, when is the derivative of this thing negative? Well, when is f prime negative? That's when f is decreasing. Now, assuming it didn't say this, but let's just say that that's at 1, 5, and 8. So when would the acceleration be negative? What's your justification? Is acceleration is negative when the velocity is decreasing. So acceleration is negative when velocity is decreasing. So where is velocity decreasing? From 1 to 5 and from 8 to 9. Oh, what a good question. Okay, so there is the accumulation of change. I hope that this helps y'all. I cannot tell you how important this lesson is. So please, please, please do your homework this evening, and peace out.